Our final speed talk is from Elio, who will be talking to us about a bespoke telemetry solution for pangolin conservation. So Elio, take it away when you're ready.
Hi, everyone. My name is Elio Challita. I'm a roboticist at the Harvard Microrobotics Laboratory. And this project is led by myself and Charles Imogor. He's a conservation biologist at the University of Cambridge. And our goal is to study white and black-bellied pangolins in Nigeria. These are among the most heavily and hunted and trafficked pangolins in the world, and we still don't know much about them. And a major reason behind that is that they are very difficult to track. They live under dense canopy. They are nocturnal, they climb and burrow, and any device we attach has to be lightweight while lasting for weeks. So existing methods, they have limitations. GPS doesn't really work that much under dense canopy, and VHF is only accurate for like around 100 meters. And there's a nice paper that was written by Charles that outlines this work. Sorry, I'm in the back. If you're interested in understanding more about challenges we get from tracking these animals in the forest. Um, so our goal is to achieve long-term accurate tracking under dense canopy with limited mass and power budgets. So instead of looking at off-the-shelf systems which do not really meet these requirements, we are building our own custom tag that is designed specifically around pangolin anatomy and behavior. It is very hard to access pangolins. So what we did is that we went to the Harvard Comparative Zoology Museum and we built our own kind of replica of how the pangolin scales look like. And this is kind of a replica that shows a pangolin skin. And we built our own tag, which is around 50 grams and combines GPS and IMU. It is mainly the tag is mainly turned off when the pangolin is not moving, and it turns on when it's doing something useful. And it takes a GPS and constructs basically the movement based on both the IMU and the GPS. And we're using that reckoning for that as well. Now for data retrieval, what we are using is basically we are attaching VHF and LoRa to a drone where we set a base camp in the forest, and over long distances we use VHF, which is proven to work in the forest, but it will give us a rough estimate where the animal is over longer ish distances. And then we take our drone when we get closer to the pangolin. We establish LoRa communication, which is basically like a low cost and low power, long range wireless communication. And we can upload the data we have without really recapturing the animal. And we can process all the data off board without really computing anything that is heavily done on the tag itself. And I guess one of the key advantages here is that we don't have to recapture the animal. And we tested this in the field recently. If anyone is from the Vancouver area, I saw someone is from the Vancouver area, they might recognize this hike here. This is in Joffrey's Lake in BC, and we tested it with different kind of intervals of GPS fixes. And we saw that, if we have a fix every 1 minute, we can get a very good estimate of where the tag is, and then the error would increase to the power two, actually, to the time to the power two, if we increase the fix to like 10 minutes or 30 minutes. So in a way, we can estimate the amount of error we can get from this, and depending on what kind of information you want to get from the tag, we can change the duration of our tags. And we're gonna, this is still under development, and but I think we're pretty close to deployment. But yeah, if anyone has any suggestions or any questions, I'm happy to answer these. And yeah, thank you.
Wonderful. Thank you so much, Elio. Super interesting. So one of the questions that I had for you is just it's such an interesting process having like the 3D printing, like being able to actually look at the scales to work with the but to see like, how your technology is going to work developing that. And I'm curious if that's like a common practice in developing attachments for hard to track species, or if there are maybe things from your development process that could be transferable to other species that are difficult to attach trackers to.
That's a great question, and I think that yeah, it is not typically used for building attachments. And for us, when we start working on these, like we want to really work. I haven't seen a pangolin yet, and it's hard to find them in zoos here in the U.S. There are only a few spots, not in the area at least. And so we were like, all right, how can we build something that is informed by the anatomy? And then we started looking at what are the available resources. We have videos and we have samples from the Harvard Museum. And then we thought like, okay, this is actually interesting. Maybe we can use that to make something that is more generalizable beyond the pangolin. So we are actually writing a paper and a method paper on how to use video information and museum samples to
Mhm.
reconstruct basically the animals without having them, basically based on their gait and how they move in the forest and all so on. It's an ongoing. It's a little bit in parallel to what our main goals are, but I think it would be interesting to the community as well.
Interesting. Yeah, please do share that when it's available for the community to read.
Mhm.
Wonderful. Well, thank you so much, Elio.